Finish up graphing our trig functions. I personally think graphing tangent and cotangent is the easiest of the six. So I'm going to throw up on the calculator that first problem we're doing on the notes, just to get a general idea of what this thing looks like, and then we'll talk about how we can get to that graph. So what does it say on the first one?
3 tangent 3 over 2.
Oh, yeah, Blake can get notes.
Okay, good to hear on something.
What?
That's cool.
That's disrespectful.
I can't do this.
All right, so this is what tangent looks like. What does it look like?
Bunch of waves.
Like
a zebra.
yeah, I was just thinking that. I was thinking zebra.
Black zebra.
Now, if I just took one of those, what would you say one of them looked like?
It's the,
It looks like a disco. So that's what tangent and cotangent look like. It looks like a bunch of disco functions. Okay. Now, what do you think between each one of these sections? What's going on between each one of these sections?
It's on the order.
It has asymptotes. Very good, Sky. So I'm going to have to find asymptotes, and notice the middle of each one of these is touching where? On the x-axis. Okay. Now, what you're going to find out is the middle, where it touches the x-axis, is halfway in between the two asymptotes for each piece. Okay. So notice which way does this one go up on?
right.
It goes up on the right side. Okay. So let's graph the cotangent one and see what that looks like. All right. So the cotangent is 2 cotangent 6 over 7. I graph that, and that's what the cotangent looks like. Very similar to the tangent. What's the difference?
It's going down on the right.
Okay, it goes up on the left instead of up on the right. Now, I want to go back to the tangent one and show you one more thing. Okay, notice what's going on here with the one that's in the middle. Okay, notice it's kind of split. The center of it is right on the y-axis. It goes up on the right side of the y-axis. It goes down on the left side of the y-axis. Let's look at what the cotangent one looked like. Notice what's going on the y-axis on the cotangent. It doesn't touch. So what's at the cotangent? It has an asymptote. At the y. So on the cotangent, the y-axis is going to be one of the asymptotes. Okay. On the tangent, the y-axis was not. Where was the y-axis?
On the x-axis. No, not
Close.
Let's go back to the graph. Notice the y-axis with this piece that's in the middle is the middle of that piece. Okay, so it's got half of it on the right, it's got half of it on the left. So that's what we need to keep in mind. But on the cotangent, what was on the y-axis? The asymptote, so that means all of it was on the right side, and there's all of one that's on the left side. So we need to keep that in mind. So those are the two things we need to keep in mind. Which direction does tangent go up on?
Right.
The right side. Which direction does cotangent go up on?
The left.
The left. The asymptotes of cotangent, the first one is on the y-axis, and then the other one is over. On cotangent, though, what do you think those asymptotes do with the y-axis? They straddle it. Good. That's the word I was looking for. The asymptotes straddle it. So that's what we want to keep in mind with these graphs. So let's look at them real quick. All right. So here's the first one. Okay. We want to get to something that's similar to what we graphed. All right. So what do you think we're going to do first?
Find the period.
Find the, just like on everything else, I want the amplitude, which is 3, and we want the period. Now, the period for tangent and cotangent is different than the other 4. What did we do to get the period for the other 4?
2 pi over
2 pi. Okay? With tangent and cotangent, we're just going to use pi. Does anybody know why we'd use pi with tangent and cotangent, but with the other 4 we would use 2 pi? thoughts on that?
Yes.
Because you're not using the longest side.
No, that's not why. I appreciate the effort though. Anybody else have any thoughts?
Does it have to do with tangent connecting to one circle?
It has to do with kind of thinking about the circle, yes. Let's think about sine real quick. What is the sign of sine in the first quadrant? Positive. In the second quadrant? Positive in the third and the fourth. Negative. Now, why do we use 2 pi for sine when we're finding the period? Because I have to go all the way around before what happens? It repeats itself. I have to go all the way around before it starts repeating itself. Same thing with cosine. With cosine, I'm positive here. What am I here? Negative here, negative, and here, positive. Again, I've got to go all the way around before my signs start repeating. But on tangent and cotangent, I'm positive here. What am I here? Negative. What am I here? Positive and here. How far do I have to go before I start repeating my signs? I just have to go to there, and then I start repeating again. So that's why tangent and cotangent are pi versus sine, cosine, secant, and cosecant are 2 pi. Because it has to do with how far you go before your numbers start repeating. Okay? Alright, so I want to use pi. So what does my period end up being on this one? 2 pi over 3 is correct. So your period, how do you think your period is going to translate to the graph?
They're going to be either the asymptotes or the middles.
Very good. It's the distance between your asymptotes is what your period is. Your period is the distance between the asymptotes. Now, what did we say was going on with the asymptotes of tangent? Either side of the y-axis. So they are on either side of the y-axis. So what am I going to have to do to 2 pi over 3 to figure out where my asymptotes are at?
Divide in half.
Divide them in half and do what? Start from the middle and go half the right direction and go the other half the left direction. So half of 2 pi over 3 is going to be pi over 3. So pi over 3 is right here. I'm going to have an asymptote there. I go pi over 3 on the left. I'm going to have an asymptote there. Okay, then what was my graph doing when we were looking at it on the calculator halfway in between those two asymptotes? It was crossing the x-axis. Okay, each piece was crossing the x-axis halfway between the asymptote. Okay, then which side was tangent going up on? It was going up on the right side. So what we're going to do is we're going to go halfway again between the middle and the asymptote, and we're going to go up to our amplitude, which is 3. We're going to go halfway on the left, and we're going to go down to our amplitude, which is 3. Then we draw our curve going up on the right. We draw our curve going down on the left. And that represents one period. Okay, we always want 2 periods when we graph, so what am I going to do to get to my second graph? Okay, I need to go 2 pi over 3, so how far is 2 pi over 3? It's 4 spaces, so I'm going to go 4 spaces. 1, 2, 3, 4. There's my next asymptote. What has to happen halfway in between those asymptotes? It has to cross the x-axis. Then halfway between that point and the right side, what does it have to do? It has to be at my amplitude, and then halfway on the left has to be at the negative amplitude. Draw my curve. Draw my curve. So let's go see how similar that looks to what we had on the graph. There's my graph. Something very similar. Okay, and I want to show you this value right here where it is 3. Okay, notice that the x value is pi over 6. So I'm going to show you on that graph that pi over 6 produces the y value of 3. So let me do that. So I want to go menu, I want to do trace, I want to do graph trace. I'm going to press enter and escape, and then I'm going to change this one to pi over 6. So pi and divided by 6, and when I press enter, what should that y value be? It should be 3 if we did it right. So I press enter, look at my y value. My y value is 3. So that's how it works out. So recap what we did here. Found the amplitude, we found the period. How do we find the period? Pi times the reciprocal of the number in front of x. Okay, then what do we do to get our asymptotes? Half the period, go that much to the right, that much to the left. That's where my asymptotes are at. Then what? Halfway is the x-axis. Halfway on the right is the top value. Halfway on the left is the bottom value. And then I just repeat it to get to them. Yes?
Oh, you just want us to just label 2?
Yeah, I just want two periods, just like we do with sine and cosine. All right, let's look at the next one. So let's revisit our graph on the cotangent. Here was my graph on the cotangent. What were some things we noticed?
Goes up on the left.
Goes up on the left.
Does not touch the y-axis.
The y-axis is an asymptote. Not really. So let's find the amplitude in the period. So what's my amplitude? 2. What's my period?
7 pi over 6.
7 pi over 6. So we know that the y-axis is a what? The y-axis is an asymptote, so we're going to go ahead and do that. Where does the other asymptote have to be?
7 boxes.
At 7 pi over 6. So how many spaces is 7 pi over 6? 7. So I know that's where the other asymptote has to be. Then what else has to happen? Has to be halfway in between. It has to be on the x-axis, so that's going to be 3.5. And then halfway between on the left, is that going to be my top dot or my bottom dot? On the left, it's going to be my top. So that's 3.5. Half of 3.5 is 1 3/4. So that's going to be right there. And then on the other side, 1 3/4, that's going to be the bottom dot. So there's that. What do I do to get to my next one? 7 pi over 6. So how many spaces is that? 7. So go 7 more spaces. 1, 2, 3, 4, 5, 6, 7. There's the next asymptote. Halfway in between has to be that. Halfway in between on the left needs to be a 2. Halfway in between on the right needs to be a -2. Up on the left, down on the right. All right, so let's pick out an x value that we can plug in to see if it matches up. So this one right here, it looks like, well, that's going to be a tough one to do. So pi over 6, that would be pi over 12. So 2 pi over 12, no, that's not what we want. That's pi over 24. So 1, 2, 3, 4, 5, 6 pi over 24. How many times does 6 go into that? That can't be right. Yeah, that can't be. No. Half of that is 12. Half of that is 24. 1, 2, 3, 4, 5, 6, 7. Should be 7 pi over 24. So let's do that. Menu, trace, graph trace, enter, exit. Where'd it go? Oh, it's 0. That's not menu, trace. There we go. Exit. So what did I say? End up with 7 pi over 12? 7 pi over 24, yeah. So there we go. So control divide, or 7 times pi and divided by 24. Here. And it gives me the y value we thought it would. It gives me the y value 2. So what do we need to know about? What do we need to know to be able to graph cotangent? Goes up on the left. Y is the first asymptote, and the other one is the period. Okay, so that's cotangent.
So you don't have the period on
You do. Because what is half of the period? It's the middle, and then what's the other half? Where my dot's at. So yes, but you really don't run into it until you run into the shifts, which is what we're getting ready to do.
Oh.
Yeah, it should.
All right, so let's look at the third one. So, what is the most important thing to get right when you're graphing tangent and cotangent?
What side it goes up on?
Which side it goes up on, and what else? Where the asymptotes are at. The asymptotes are the key to graphing tangent and cotangent. If you get the asymptotes in the right place, you're going to be good to go. All right, so on this one, amplitude is for the period 4 pi over 3, and the shift on this one
4 pi over 12.
4 pi over 12, which just gives me pi over 3. And we're going to the right. Now, when we were doing the other 4, we keyed in on this number right there. And if it was pi over 2, that meant 1 period mark. If it was pi, 2 period marks. And if it was 3 pi over 2, 3 period marks. Now, for tangent and cotangent, slightly different. Pi over 4 is 1. Pi over 2 is 2. And 3 pi over 4 is 3. So that's what you need to know for tangent and cotangent. All right, so what do I want to do?
Why is it 4 pi over 3? Oh, that's for. Okay, I was looking at the wrong thing. Never mind.
All right, what do we want to do?
On your period.
Find the,
I want to find the original asymptotes, because on this time I'm moving it, so I want to know where are the original asymptotes at. So how do I find out where the original asymptotes are at?
graph it, half the shift.
Half of 4 pi over 3. So what's half of 4 pi over 3 going to be? 2 pi over 3. So how many spaces is 2 pi over 3?
4.
4. So if I go 4 spaces to the right, that's one asymptote. 4 spaces to the left, that's where the other one is at. Now, Bobby asked, how come we didn't break up the bottom like we did with the other 4? If you're not doing a shift, you really don't need to break it up. But if you're doing a shift, you want to break the bottom up just like we did with sine and cosine. So I need to go halfway, and I need to go halfway. Because now I have to move my asymptotes, whatever my shift is. Okay, and how much do I want to move them? I want to move them 1 period mark to the right. So I'm going to take this one on the left, and it's going to move to there. So that means I've got an asymptote there, and I'm going to move this one over to there, and I've got one there. Once I know where my asymptotes are at, then it should be very easy to graph. So what do I have to do now? Halfway is on the x-axis, and then halfway on the right, is it going to go up or down? It's going to go up. And halfway on the left, it's going to go down. There's the graph of the first period. Okay, what do I do to get to my next period? Go over 8 spaces. How did you know 8, Rachel? And the length of the period is 8 spaces, so that's how far apart my asymptotes have to be. So 8 spaces to get to my next one. So that has to be there. Then halfway between those two asymptotes, I've got to be on the x-axis. Halfway on the right, I've got to be at 4. Halfway on the left, I've got to be at -4. Then I draw my curves. And we need to understand that what keeps happening as I go to the right, what it keeps happening as I go to the left. They keep these graphs keep repeating. So on this one, we found the amplitude, we found the period. Since I was dealing with tangent, what did I have to do with the period? Cut it in half and go both directions. So I went 4 to the right, 4 to the left. Those are where my original asymptotes are. Then I had to do my shift, which was right pi/3, which is 1 period mark. So I moved them over 1 period mark. Those are my asymptotes. Halfway in between has to be the x-axis. Since it's a positive tangent, it goes up on the right. So halfway on the right is at 4. Halfway on the left is at -4. Questions on that one? Okay, let's look at a cotangent. Let's look at 4. So I have y equals -2 cotangent of x plus pi/2. Amplitude 2. Period. Period is pi. What about my shift? I'm going to the left. Pi/2. How many period marks is that? It is 2 period marks. All right. What's next? The original asymptotes. So where are the original asymptotes at? The y-axis and the period, which is pi. Then I take half of that and take half. Alright, then what do I want to do? Shift it to the left, so I want to move my asymptotes to the left. How far do I have to move them to the left?
2 period marks.
2 period marks. How many spaces is 2 period marks? 3 spaces. So I need to go 3 spaces to the left. So that one's going to move to there. I've got an asymptote. This one's going to move to there. There's that asymptote. From there, it should be very easy to graph. What has to happen next? The middle has to be on the x-axis. Now, cotangent usually goes up on which side? The left. What's different about this problem? It's negative, so which side is it going to go up on? It's going to go up on the right. So the negative just flips which side it goes up on. So halfway on the right is at 2. Halfway on the left is at 2. Draw your curves. How far do I need to go to get to my next asymptote?
6 boxes.
6 spaces. So 6 spaces gets me to my next asymptote. I take half. Half on the right is at 2. Half on the left is at -2. Curve going up on the right. Curve going down on the left. Questions on that one? All right, let's look at the combination one and we're done. So look at 6. Let's jump to 6. All right, what's my amplitude? 1. My period? Haven't heard it yet. 5 pi/3. All right, what about my shifts? Up 2. And we're going to the right. How much are we going to the right? 15 pi over 12, which is 5 pi over 4. How many period marks? 3 period marks. All right, what do I want to do next?
Graph the original.
Original asymptotes. So since this is cotangent, where are the original asymptotes?
One.
The y-axis and the period. So how many spaces to get to 5 pi over 3? 10. So 10 spaces. So there are the original asymptotes. I need to cut that up. So half of 10 is 5, and half of 5 is 2.5. All right, so then what?
Right. 3 periods.
I want to go right 3 period marks. So that means this one is going to go all the way to there. Okay, and what can I do to get to the other one?
Just count how many boxes.
Yeah, how many boxes do I need to count? How far apart were the asymptotes originally? 10. So I need to go 10 to get to that next one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's that. Half of 10 is how much? 5. So, but I need to do something before I put my other marks on there. What else do I need to do? I need a new x-axis. So I want to put a new x-axis before I get my dots on there. So it was up to. So there's my new x-axis. Now I can get the dots. So 5 is halfway. So 1, 2, 3, 4, 5. And which side is this one going up on? Goes up on the left because it's a positive cotangent. So that means I want 2.5 to the left. So 2.5 to the left, and my amplitude is 1. 2.5 to the right, my amplitude is 1. So that's what one piece looks like. Now, obviously, I have to go back to the left to get another period. How far do I need to go to get to my next asymptote? 10 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Half of 10 is 5. So 1, 2, 3, 4, 5 has to be the midpoint. Half of 5 is 2.5. So 2.5 to the left, it's got to be up. 2.5 to the right, it's got to be down. There's 2 periods of the graph of this function. Okay, most important thing about graphing tangent and cotangent. Get the asymptotes in the right spot. If you get the asymptotes there, then everything else falls into place pretty easy. How do I find the asymptotes of tangent?
Between the period.
Half the period to the right and half the period to the left. Those are where it's at. A positive tangent goes up on which side? The right side. A positive cotangent goes up on the left. Where do I get cotangents asymptotes from? The y-axis and the period. That's all there is to graphing tangent and cotangent. Any questions?